Hello everyone, welcome again to Ganit. Good evening. I hope your preparations are going all right. You are taking care of yourselves. You're not over stressing for the exams. So here we are again. We are going to talk about trigonometric questions now. In the previous video, we had talked about various themes, and I had tried to explain in whatever way I can. I have asked you multiple times in the previous video also that this all the theme based study that we are doing in trigonometry, it's only for one reason really, to take that first step correctly. Okay, so let's talk about the questions now, and we are going to solve some questions which have been asked previously in board exams. We are also going to talk about some important questions which may not have been asked in board exams, but are really important as per my opinion. And let's see. Okay, let's not further delay it. Let's start with the questions. So this is a question that has been asked in previous board exams. So let's see what we have. So we have a question where sine is in the numerator and cos is in the denominator, and we have to prove it equals to tan theta. All right. So now please understand, sine theta by cos theta in itself is good enough to prove tan theta, right? So we will try, and so our objective is really that in left hand side we are chasing sine theta by cos theta. So let's see here. I can take sine theta common here, and it will become 1 minus 2 sine square theta by cos theta. I can take common, and it will become 2 cos square theta minus 1. Now by this step, I am 100% sure that if I was in your place, I would be writing this paper. By now I would have realized that somehow I need to get rid of this bracket and this bracket, because I have already found my answer. I'm already seeing sine by cos. I'm 100% sure you are also seeing this, right? So the idea is to get rid of this bracket in numerator and denominator. And how can you really get rid of two brackets which are in numerator and denominator? They can only be cancelled if they are same. But are they? They're not. The first bracket in numerator has a sine square. The second bracket has a cos square. But then again, God is kind, Sine square plus cos square is equals to 1. We have an identity which relates sine square and cos square. So what we can do is, we can replace sine square with 1 minus cos square, or we can replace cos square with 1 minus sine square. And then the most important part in trigonometry, we hope and we pray to God that this works. Okay, so let's try it. So we have a sine theta by cos theta. I'm going to take my bet on the numerator. So 1 minus 2 and 1 minus cos square theta. Now, if you see, I am using the brackets, and this is where a lot of you lose the plot. Okay, sorry, 1 second. So this bracket is not needed here. Yeah. So please understand, here I have used a bracket because I was replacing sine square theta with 1 minus cos square theta, because sine square theta plus cos square theta is equals to 1. Remember, in previous video that we did on trigonometry, we were talking about this thing, that whenever you see 1 minus cos square theta, you have to replace it with sine square theta, or the other way around as well. Not have to. I mean, you can, and if it makes your life easier, why not, right? So we will be back to the question that we are doing. So that's exactly what I'm doing. I'm replacing 1 minus cos square sine square theta with 1 minus cos square theta. And denominator is 2 cos square theta minus 1. Now if you see, there is still a hope. Now we can see some beacon of light, because there's a cos square in numerator and there's a cos square in denominator. So now we start praying. This is where we start hoping and praying, okay? So let's, along with some maths, of course, okay? So sine theta by cos theta is 1 minus 2 plus 2 cos square theta. And precisely that's why I had put the bracket, because wherever the minus signs are involved, wherever the minus sign is there, it just freaks me out every time. I'm very scared of minus sign, because there are so many mistakes that I have made, and so many times I have had to redo the whole question because of that one silly mistake of minus sign, that I don't want to make that mistake ever again. So 1 minus 2 is basically what? We have a minus 1. So we get 2 cos square theta minus 1 over 2 cos square theta minus 1. in numerator and denominator both. And then we have a sine theta by cos theta already tagging along. So 2 cos square minus 1, 2 cos square minus 1 eventually cancels out. The God has listened to our prayers. We have sine theta by cos theta, which is eventually tan theta, and which happens to be our RHS. So we have proven this question. I hope you understood what I did here. Very simple explanation, very simple question. You just had to replace sine square with 1 minus cos square, and be careful with the minus sign. Okay, don't forget the praying part also. Let's move let's move to the next question. Okay, so I don't think the praying might help in this one. We might have to actually do some maths here. So let's see. So we have a 1 plus cot and cosec, tan and sec. Now, please understand, cot and cosec are directly related to each other, and tan and sec is also directly related to each other. So there could be multiple ways to approach this question. Okay, you may consider replace one with cot square theta. Sorry, cosec square theta minus cot square theta. You may replace one with sec square theta minus tan square theta. That can be an approach, not my approach. I am, I am a person who really is scared of taking long steps. Long steps as in steps where there are 5, 6 terms suddenly. You replace one with an identity, you get 2 more terms. One is a nice looking number, and we replaced it with 2 more trigonometric terms. So in one bracket, we have 4 terms. So 2 brackets, how many terms we have? 8. I am scared of that. I'm not going to take that approach. So cot theta can be written as cos theta by sine theta. I hope you will all agree to that. Cosec theta can be written as 1 by sine theta. That's the approach I'm going to take. I'm going to simplify this bracket further. If I take the LCM, I'll get sine plus cos minus 1 by sine theta. That's my first bracket. Second bracket, 1 plus sine theta by cos theta and plus 1 by cos theta, which gives me cos theta plus sine theta plus 1 by cos theta. Now, by this stage, I have already started seeing algebra. Remember remember how I told I'm going to brag about it every time there is a reference, So this is a reference. I am seeing a minus b and a plus b in the question that we are doing. I'm going to show it to you. So I'm talking about sine plus cos as a, and then your 1 is b. So I have a minus b and a plus b. But you have to be careful while using the identity. So a minus b times a plus b is what? A square minus b square. So sine theta plus cos theta squared minus 1 squared. And denominator is sine theta cos theta. Remember, you have to use a plus b whole square. So if any one of you is in a hurry and you are thinking that sine theta plus cos theta whole square can be written as sine square plus cos square, because that's an identity after all, right? So why not? But no. Please remember, if it is a binomial, if it is an a plus b sort of situation, you have to use the algebraic identity. And that's precisely why I told you the a plus b whole square. I didn't tell you the a minus b whole square. Nothing like that. I'm just bragging, okay? So this is sine plus cos whole square. So we have sine square theta plus cos square theta plus 2 sine theta cos theta, a plus b whole square minus 1 by sine theta cos theta. Now we all know that sine square plus cos square is 1. So what we get, 1 plus 2 sine theta cos theta minus 1 over sine theta cos theta. And 1 and minus 1 cancels out. What do we have? 2 sine theta cos theta by sine theta cos theta, and this whole thing cancels out, and we get 2, which is our RHS. So again, your approach should be your own. I would not really discourage you from doing what comes naturally to you. But if there's a better way, if I would be you, I would not hesitate in learning it. Maths is all about learning new approaches, isn't it? So if there's a better way, if there's a way which can save some time and some pain, Why not, right? So let's move on to the next question. Well, that looks rather simple. Um, so we have a 1 minus tan in numerator, 1 minus cot in denominator. So tan and cot are reciprocal of each other, and that's a connecting point for sure. RHS has tan square, so obviously I will not change the tan to cot. I would rather change cot to tan, and then hope. That's a very important part of any trigonometry question. You hope, you pray, right? So 1 minus tan theta by 1 minus 1 by tan theta, right? So numerator will be 1 minus tan theta. Denominator will become tan theta minus 1 over tan theta. So when you have this thing, what happens usually is the tan theta will go up. So it will become tan theta times 1 minus tan theta over tan theta minus 1. Now this is where I'm going to talk a little bit about arithmetic, algebra, arithmetic, whatever you call it. So A minus B, actually algebra. So A minus B is basically B minus A with a negative sign. I'll show you how. So if I open this bracket, this can become minus B plus A, which can be rewritten as what? A minus B is the same thing. So if I have A minus B in one place and B minus A in another place, don't lose your heart. It's pretty much the same thing. You just have to take a minus sign out. That's exactly what I'm going to do here. So this thing becomes tan theta, 1 minus tan theta by 1 minus tan theta and a minus sign out. And now 1 minus tan, 1 minus tan cancels out. The minus sign goes up. We have a minus tan theta. And this was always going to be what? Whole squared. So minus square is positive and tan square is tan square theta. So RHS. I would honestly believe that this is more an algebra question than a trigonometry question. I barely used any trigonometric identity, right? I just used cot theta is 1 by tan theta. I mean, we all know that. I mean, there is no challenge in this question whatsoever. This was asked in a board exam actually. All right. Oh, I have got all the rights to brag now. So first I'm going to show you what I was blabbering about in my last video. This, my dear, a cube plus b cube is what we were talking about. And this is directly applicable in a question. I mean, look at that. It's beautiful. The question says factorize sine cube plus cos cube and hence prove the following identity. That's amazing, right? So factorize sine cube plus cos cube. Where do we really factorize? Do we factorize in trigonometry? No. We factorize in algebra. So this is a direct implication of what we were talking about in our earlier video, right? So sine cube plus cos cube theta, they want us to factorize. Imagine guys, factorize, not solve, factorize, not prove, factorize. So let's factorize this. A cube plus b cube is a plus b and a square plus b square minus ab. We have seen that before, haven't we? I'm thinking, where have we seen that? Yeah, guess what? In the last video that we had done. So sine cube plus cos cube is sine theta plus cos theta. And then we have sine square theta plus cos square theta minus sine theta cos theta, right? So this is your factorization part. So when they say factorize, this is your factorization. And now we are going to solve this thing. So we have a sine cube plus cos cube in numerator. So we will replace it with sine plus cos, sine square plus cos square minus sine cos, right? Whole upon sine theta plus cos theta and then plus sine theta cos theta. So this bracket completely cancels out. We have a sine square plus cos square, which is 1. So we have 1 minus sine theta cos theta plus sine theta cos theta. And guess what that gives us? 1, the RHS. And that's why, my friends, knowing algebraic identities is super, super important. Okay. Now, let's move on to the next question. Again, it's a board exam question. So we have a sine theta plus cos theta is equals to root 3 situation. Oh, nice. This is again more algebra than you think. Let's see. So sine theta plus cos theta is equals to root 3. And they are asking us the value of sine theta times cos theta. Now think about it. Where have you seen a plus b given to you and ab being asked from you? Isn't that the situation? I mean, they have given sine plus cos and they are asking sine cos. So you pretty much know it, right? Algebra, you guessed it, right? So a plus b whole squared is equals to what? A square plus b square plus 2ab, right? So what we do, we whole square both the sides. So we will get sine square theta plus cos square theta plus 2 sine theta cos theta is equals to 3. Square root of 3 when it's squared becomes 3. Please know that. Okay, sine square theta plus cos square theta is how much? 1. So we have 1 plus 2 sine cos is equals to 3. That will go that side. So 2 sine cos is equals to 3 minus 1, which is 2. So sine theta cos theta is 1. Right? Now, this much is clear? Okay. Let's talk about the second part. So this question had two options. I'm going to explain both the options. It is up to you which option you pick in the actual exam. Okay, but I will explain you both the options. So sine alpha is 1 by root 2 and cot beta is root 3. Now cot beta is root 3. This is an interesting piece of information. Please understand, tan 60 is root 3 and tan 30 is 1 by root 3. So cot, if it is giving you root 3, that means tan 30 would have been reciprocal, right? That means your beta is 30 degree and this means your alpha is 45 degree. And guess where you have seen this before? I'm going to show you exactly where you have seen this before. So I think here, if I'm not wrong, yes. So when I was talking about this thing that tan theta is equals to 1 by root 3, I will conclude from there that theta is equals to 30 degree. I would want to extract the value of theta. Rather than going ahead with the question, I would want the angle for myself. And that's exactly what I'm going to do in this question that we are solving right now. So I have alpha as 45 degree, beta as 30 degree. And after that, whatever comes, I will just replace the value because I have alpha and beta now. So cosec alpha and cosec beta. Let's see. So cosec alpha means reciprocal of sine alpha. And sine alpha was, sine 45 was 1 by root 2. So cosec alpha will be what? Root 2. And cosec beta will be what? So cosec 30 degree. Sine 30 is what? 1 by 2. So cosec 30 will be what? 2. Right? So 2 plus root 2, which you can take root 2 common and you will get root 2 plus 1. That's your final answer. Okay? So I hope this is clear. I have not used any special technique. Very simple concepts, very relatable concepts. You would have done this a million times before. All right, let's see. So we have sine theta plus cos theta is equals to root 3. We have to prove tan theta plus cot theta is equals to 1. Wow, that's a good question. That's a very, very nice question. We have to prove that tan theta plus cot theta is equals to 1. So what we're going to do now is sine theta plus cos theta is equals to root 3. There is no other way to come out of the root 3. We have to factorize, square it. So what we will get? Sine square theta plus cos square theta plus 2 sine theta cos theta is equals to 3, right? Sine square theta plus cos square theta is what? 1. It goes that side. So what do we get? 2 sine theta cos theta is equals to 2. 3 minus 1, right? So what we basically get is sine theta cos theta is equals to 1. And you know what that gives us? It gives us that sine theta can be written as 1 by cos theta, or cos theta can be written as 1 by sine theta. What are they asking in the question? Tan theta plus cot theta is equals to 1. Let's see. What is tan plus cot in terms of sine and cos? Sine by cos plus cos by sine, right? This was one of the themes that we talked about, changing of tan to sine and cos, right? Here, theme number 2, if you see, changing tan theta to sine by cos and cot theta to cos by sine. And this is pretty much a very, very practical application of the theme that we talked about. So we take the LCM and everything. So what do we get? Sine square theta plus cos square theta whole upon sine theta cos theta. Now sine square theta plus cos square theta is 1. We already know that, right? Denominator is the problem. But is it a problem? Didn't we already find sine theta cos theta is equals to 1? So what we do, we take this value and come back here and replace it with 1. We get 1 by 1, which is equals to 1. And therefore, we can say that tan theta plus cot theta is equals to 1. Where did we have tan theta plus cot theta? Right here, which gave us sine by cos plus cos by sine. I hope this is clear, and I hope you can see why the themes that we kept talking about are so important. Okay, so wherever you see a square root, what you learn from this question is wherever you see a square root sort of information, I would say blindly go with squaring both the sides. Most of the times it helps. Okay, all right, let's move to the next question. Oh yes, beautiful. This is a very, very important question. You can find it everywhere. You can find it in any textbook you know for grade 10th, any sample paper, any question bank. This question is omnipresent. This is like God level question. Not difficult, not difficulty wise, but it's a very, very important question because of the trick involved in this question. And the trick is do not disturb the denominator. Whatever you want to do it. You want to go on an adventure, go ahead. Do not touch the denominator, please. So whatever work you want to do, work it in the numerator. And I'm going to show you with proof that why we don't bother the denominator. So any question, any fraction where 3 terms are involved, denominator, the moment you reach in tan and sec or cot and cosec, after that stage, you will not disturb. We are already at that stage in this question, so we are not going to bother it. So let's see what we can do then. So the numerator will be tan theta plus sec theta minus 1. I'm going to write as sec square minus tan square theta, right? Denominator, please do not touch it. Let it be. Let it have the moment. So sec square minus tan square, guys, is nothing but a square minus b square. So I'm going to further simplify this. Tan theta plus sec theta in one bracket minus sec theta plus tan theta in one bracket and sec theta minus tan theta in another bracket whole upon tan theta minus sec theta plus 1, right? Again, not touching the denominator. In numerator, if you see tan theta plus sec theta is common, not able to see it? Okay. X minus xy. X is common. 1 minus y will remain. Now it's okay. We have x and xy, correct? So I am constantly searching for algebra. Constantly, all the time. In a trigonometry question, I'm always looking out if there is an algebra, there is an algebraic identity, or if there is an algebra situation existing. I found one factorization related stuff, I'm going ahead with it. So tan theta plus sec theta is common. And in the bracket 1 minus, and there's a minus, remember. So this will open as sec theta plus tan theta, because that minus will change this minus to plus. Okay, and whole upon tan theta minus sec theta plus 1. And if you see, that minus sec theta, tan theta 1, 1. So the whole bracket, do not cancel the individual terms, guys. The whole bracket. If they are entirely same, cancel it out. So what do we get? We are left with, this is why I was not disturbing the denominator, because denominator eventually gets cancelled out. It's completely shut down. Denominator is gone. You didn't even touch in the step 1. You didn't even bother about the denominator in step 1. And by step number 3, it was gone. Right? So we are left with what? Tan theta plus sec theta, which is nothing but sine theta by cos theta, and 1 by cos theta, right? That gives us sine theta plus 1 by cos theta, which is our RHS. So I hope you have understood all these questions that we have done. I hope you were able to spot the themes and the identities that we had discussed earlier. So we are going to close the session for today. In the next session, we are going to talk about some more trigonometry questions. Probably there is going to be a couple of more, uh, at least 1 or 2 more sessions where I will talk about all the identity questions, and then we will move on to the heights and distances on the application part of trigonometry. Okay, so till then, keep preparing, stay confident, stay calm. Okay, good night.